Hello. So for this video here, we're going to start on page 2. So I'm going to show you how to solve the problems. One thing I want you to be aware of is that if you want to find the average speed, and you're given different speeds for a trip, so in other words, if you're going for 1 hour at 58 meters per second, and for the next 2 hours, you're going at 30 meters per second, and for the next hour and a half, you're going at, 20 meters per second. To find the average speed, you cannot just take these speeds and divide by 3, because these rates are happening for different times. Okay, so just make sure you're aware of that. If they were happening for the same amount of time, then yeah, you could do that. All right. Suppose an ostrich runs 1.5 kilometers at a speed of 58 kilometers per hour, and then runs another 1.5 kilometers at a speed of 29 kilometers per hour. What is the speed? The ostrich's average speed. Okay. So average speed is total distance over time. Well, the total distance here is 3 kilometers. Now, how long did it take to do this 3 kilometers? I think we can use the V equals D over T for each part of the problem. So in this case here, the T will be D over V. So it's going to be 1.5 divided by 58. So I should do 1.5 over 58 here. I get a number. Okay? I'm sorry. And add time for the other part of the and add the time for the other part, so that's going to be 1.5 divided by 29. Okay, so I'm going to try that on my calculator. So 1.5 divided by 58 plus 1.5 divided by 29. And I'm going to do 3 divided by that number. My answer is 38.67. And that's in kilometers per hour. So I'm going to leave it in kilometers per hour. All right, let's look at number 2. Sally travels by car from one city to another. She drives 30 minutes at 80 kilometers per hour. So just be careful with the mixed units here. We're talking about hours and we're talking about minutes. 12 minutes at 105 kilometers per hour and 45 and blah, blah. And she spends 15 minutes eating. So even if you're resting, you have to include that in your speed. Okay, so you have to include that in your time, basically. Determine the total distance traveled. So what you have to do is that you have to take each part of the trip and do V equals D over T for each part, okay? And find the distance. So basically this means that D is V over T. And you do this multiple times. So the V here is 80, but the time is half. So that's 40 kilometers. That's half an hour. The V here is 105. The time is 12 over 60, so that's 1/5 of an hour. And that should be 21 kilometers. And for the last part, you're going to do, what is it? You do 40, yeah, 40 times 45 minutes is 3/4 of an hour, so that's going to be 30 kilometers. And you just add this, and you should get 91 kilometers. Okay, so for this part here, it's 91 kilometers. Now to find the average speed, you take the total distance over the total time. Well, this is 91 over the time here is 30 and 20 and 45 and 15. So how much time is that? That's 60. And that's another 50. So that's 110. It looks like that's what it is. Yeah, 110 minutes. So I'm going to do 110 minutes divided by 60 to get time in hours. So it's 91. Okay. I think I missed something here. Okay, 30 minutes. Oh, not 2012. That's what I messed up. So that should be, I think should be 102. Okay, so let me try it again. 91 times 60 divided by, okay, let me just add this again. This is 42 and 60. Yeah, 42 minutes, 45, so that's 60, 72, 102. 102 divided by 60, that's my time. Put that times 91. So I get 53.53 kilometers per hour. I talked about the velocity in the first video of this speed and velocity video, part 1. So we're going to try to do number 3. Ellen walks 3 miles east. So she goes this way, 3 miles. She makes a 40-degree left turn. That's from her perspective. So she kind of like turns this way. This angle here is 40. Okay? And she goes for another 2 miles. Okay? And she does this in 52 minutes. And she does this part here for 30 minutes. Okay? What distance did Ellen travel? So with distance, it's pretty straightforward. It's 3 plus 2, which is 5. What's her speed? Well, you're just going to have to do, in miles per hour, you're going to do total distance, which is 5 over total time, which is 82 minutes. But to change it to hours, you divide it by 60. So it's going to be it's going to be 3.66 according to what I have here. 3.65. So 3.66 miles per hour. That's her speed. Now, her displacement is a different story. So to find the displacement, I'm going to get rid of that. So if this angle here is 40, this angle here is 140. Now her displacement is this line that I'm going to draw in red. So that's her displacement vector, right? So to figure that out, I can do law of cosines or I can do the chart, and I'll show you both ways. So to do the law of cosines, which I think is easier in this case, it's going to be 2 squared plus 3 squared minus 2 times 3 times 2 cosine of 140. And you would take the radical of that and get rid of this squared. So if you do it that way, you should get, what is that, 9 plus, that's 13. 13 minus 4 times 3, that's 12 cosine of 140. And I'm going to take the square root of that. So I get 4.71. 4.71 miles. Okay? Now, I need to figure out this angle here, so I'll call it theta. Okay? So I'm going to do law of sines. Sine of theta over 2 equals sine of 140 over this distance here, which is 4.71. So with the math here, we should get 2 sine of 140 divided by 4.71, and we take the inverse sine of that, and the angle is 15.83 degrees. Okay? Now let's see if that makes sense. Well, if this is 4.71, this is 15.83, so what's left here? So what is that? 155.83 minus 180. So this other angle is 24.71. So I think the triangle makes sense. Okay? You have 140 and you have the longest leg across from it, etc. Right? Okay. And we have to say at 15.83 north of east. Okay? I said 15.90, but that's close. Okay, now let's look at it the other way. The other way you would have to take your two displacement and break them down. Here's the 3 miles, and here's 2 miles. And this is the resultant that I will call D. This is the x component, this is the y component. For the 3, it's positive, and it's 0 here, because it's just going to the right. For the 2, it's positive and positive. Okay. So for the 3, it's basically just positive 3 here, and 0 in the y. For the 2, it's 2 here. This is the x component, this is the y component, this is 40 degrees. So this is basically going to be 2 cosine of 40, and this is going to be 2 sine of 40. So let me see what that is. Okay, 3 plus 2 cosine of 40, so this is 4.53. Okay, and 2 sine of 40 is 1.29-ish. Okay, so and they're both positive, which means I'm going to be going in the northeast direction. So I make that triangle, just like we did in vectors. In vector treatment, 4.53 here, 129 here. Find out what this D is here, and find out what that angle is. So you can do Pythagorean theorem, okay? And you can do the basic trick to find the angle. So I got 4.71. I think that's what we found earlier. And for the angle, I do second tangent. In other words, the inverse tangent, 1.29 divided by 4.53. And I get about 15.90 degrees, which is close to the answer we got earlier. Okay, so it's about the same thing. Now to find the velocity, okay, the velocity is displacement over time. So if I take the vector displacement and I divide it by time, which is positive, the direction of the vector does not change. Okay, so basically V and D have the same direction. So I don't have to worry about the angle. If I want to find the V, all I have to do is take my displacement, which I think was 4.71, and divide it by the time after they change it to hours. Okay, so the 52 minutes added to 30 minutes, that's 82 minutes. You divide it by 60 to get that in hours. Okay. All right, let's look at number 4. A plane is flying due south at 500 miles per hour for 2 hours. The pilot, okay, so it's going in this direction for 2 hours. Makes a 60-degree right turn from his perspective. Okay, he turns right. Okay, he travels for 550 miles per hour. I mean, at 550 miles per hour for 90 minutes. Okay, so I think we have to figure out what this distance is here. So if we do v equals d over t, this is going to be 1,000 miles. The other one is going to be 550 times 90 minutes, which is an hour and a half, times 1.5. This is 825 miles. Okay. Find the plane's speed and velocity. Speed is easy. Speed is distance over time, total distance. So it's 100 plus 825, so that's 1825. Now, how long did it take to do that? 2 hours and an hour and a half, 3.5 hours. Okay. In the question, I think you should have said find the plane's average speed. Yeah. And I'm going to divide that by 3.5 hours. And I got 521.43, close to what I have. 521.43 miles per hour. Okay. Now I'm going to try to find the velocity. Now the velocity is displacement over time. So now the displacement is basically the direct line that connects the very first starting point to the very last destination. So this is the displacement vector. So how do I figure that out? Not a big deal. So this angle here is 60. which makes this angle here, oops, 120. So now we're going to do the law of cosines. So I'm going to do d squared equals 825 squared plus 1000 squared minus 2 times 825 times 1000 cosine 120, and I can just take the square root of that basically. Okay, so that's going to be, all right, 825 squared plus 1000 squared minus 2 times 1000 times 825 cosine of 120, and I take the square root of that, and I get 1582.92 miles. Now to find the velocity, I just take that number, okay, and divide it by 3.5 hours. So if I divide that by 3.5, I should get 452.26 miles per hour. Let's hope that it's right. Yep, it is. Now we have to find the angle. And I need to find the angle always with respect to east or west. So I have to find this angle here. But before I do that, I can find what this angle is. Okay? So I'm going to do law of sines for that. So sine of this angle is question mark over 825 is sine of 120 over this the d here, which I found earlier to be 1582.92. So this question mark angle is, so I'm going to do 825 sine of 120 divided by 1582.92. Take the inverse sine of that. So it's 26.83. Now, this theta and this question mark are complementary angles. So I'm just going to subtract that from 90. And this angle here is 63.17 degrees. Look at my answer key. That's what it is. Now here I have to add. See, a velocity with that direction is incomplete. At, what did I say? I say 63.17 degrees. When you come back here and look at it, it's towards the south direction from the west. So south of west. Now we're on page 5. Now, to do these problems here, what you need to do, you have to take each phase of the trip, and I'm going to cheat a little bit here. I'm just going to see how I broke this down. So I broke it down by 2. Each box is 1, basically. 6, 8, 10. Now, to figure out how you break it, and that's basically, I'm looking at the total, the whole time that I traveled. So I did 4 seconds and 3 seconds, that's 7, and 2 seconds, that's 9. So I need at least 9 seconds. How much distance do I need? Or how much distance did I cover? I covered 100 here. Okay? Starts for 3 seconds, so nothing is happening. And then you cover another 80. So I cover 180. So I cover 180. So I have to make sure that I can fit at least 180 in there. So I broke this down by 40, 80, 120, 160, and 200. Now, how do we graph this information? Okay. So in the first 4 seconds, after 4 seconds, I should be at the 100-meter mark. So 4 seconds, 100. Just do this. The ruler, of course. Okay? Okay, that's what it should look like for that part. Okay? Now, for the... No, I did it in the wrong place. It should be here. Okay? For the next 3 seconds, nothing is happening. So between 4 and 7 seconds, nothing is happening. So you're not moving. And then, after another 2 seconds, I travel 80 meters from the 100. So I should be at the 180 at 9 seconds. So here's 180. That's where I should be. Okay? and all the other ones are kind of like that. So you just have to go to the answer key and see how it's how they are done. Okay. So I think we can try another one. So let's try maybe number 3, I guess. Yeah, let's try number 3. Okay. Let's see how much time I need. I need 2 and 3. That's 5 and 3. I need 8. So I'm going to 2, 4, 6, 8, 10. So I need to get up to 8. Now how much distance do I need? I need 60. I stop for 3 seconds. And then I go for another 150. So I need 210. Okay? Now the way I broke this is that I broke it every 2 boxes is a 60. Yeah. I think that's what I did. Yep. Okay. This is a position time graph. Okay. Now, for first, after 2 seconds, I should be at the 60 meter mark because I travel 30 meters every second. So after 2 seconds, I should be at the 60. So I should be here. Then I stop or the car stops for 3 seconds. So between 2 and 5, there's nothing happening. Okay? And then from 5 seconds to 8 seconds, I go 150 meters. So it's 150 from the 60. So I should be at the 210. So 210 is pretty much right there. Yeah. Should look like that. So these are considered extremely, extremely easy. Okay? So I think I got that right. Number 5. You are driving home from school steadily at 65 miles per hour for 130 miles. So that should take you 2 hours to complete that trip, that part of the trip. It then begins to rain and you slow down to 55 miles per hour. You arrive home after 3 hours and 20 minutes. How far is your hometown from school? So I think what we should do for this is figure out how long you've been driving for 55 miles per hour. So 3 hours and 20 minutes is 3.33 hours repeating. Okay, you subtract the 2 hours that you were driving at 65, that should give you 1 1/3 of an hour. Okay, and you can figure out the distance by you drove at 55 miles per hour by doing V is D over T. So 55 is D over 1.33 repeating, and that should give you a distance equal to. Okay, I didn't do that, so I'm going to try. So 55 times 1.3333 repeated. So this is about 73.33 miles. Okay, and then you would just take that and add it to the 130, and you should end up with 203.33 miles. That's how long you've been. That's how much distance is your home from school. So you add 130 here, so 203.33. What is your average speed? Average speed is distance over time. Okay, so the average speed is going to be total distance, which is 203.33, divided by total time. It took 3 hours and a third of an hour. So if we take 203.3333, okay, and divide that by 3.3333, we should get about 61 miles per hour. So that's your average speed. All right. Number 6, an airplane travels 2,100 kilometers at a speed of 800 kilometers per hour. Then it encounters a tailwind that boosts its speed to 1,000 kilometers per hour for the next 1,800 kilometers. What was the total time for the trip? Okay, so I think we can do V equals D over T here. So the time for the first part is just going to be 2,100 divided by this marker divided by 800, and that should give us 2100 divided by 800. So that should be 2.625. Then you do it for the other part, which is 1800 divided by 1000, and that should give us 1.8 hours. So if we add up these two together, plus 1.8, should get 4.425 hours. And you have to show the work, of course. You have to write your formulas and stuff like that. What was the average speed? Well, the average speed is distance over time, total distance. So we did 2100 and 1000. I'm sorry, and 1800. So that's 3900 divided by that 4.425. And the answer should be 881.36. And that's in kilometers per hour. Number 7. For number 7, it took, you hear the sound hitting the pins 2.5 seconds after you release it. But it took less than 2.5 seconds for the ball to hit the pins, because it takes sound some time to come back from hitting the pins to your ears. Okay? So you have to subtract that small amount of time. So the V of the ball is distance that the ball travels over the time. Or I can do delta X here. Equals, now, it travels 16.5 meters, but it definitely did not take 2.50 seconds. It took 2.50 seconds minus the time it took for the sound to travel 16.5 meters to reach your ears. Just try to imagine that. Now, the time it took for the sound to travel from hitting the pins to your ear, okay, so you do the V for the sound is distance over time. So the time is the distance, which is 16 and a half, over the speed of sound, which I think they've given us as 340. Okay? So I have to subtract this little bit of time here over 340. And you would put that in your calculator, and you would get, I didn't do it, so it's 2.5 minus 16.5 divided by 340. Okay, and we're gonna do 16.5 divided by that. So speed is 6.73 meters per second. If we did it just with the 2.5, it would be different. It would be 6.6. Okay. All right, let's look at this. These problems are a little tricky, so let's look at number 8. One night at the horse race at the Meadowlands racetrack, the horse Anti-Science was coming into the final stretch. Was in the lead by 24 feet, racing along at 12 feet per second. When my physicist released that extra burst of, okay, so Anti-Science is here, my physicist is here, okay, and this is the finish line, finish, okay. How long does it take until the horses are neck and neck? So basically, their position is the same. So I have to follow exactly what I did here. So in here, I thought of this as a number line. So I picked this as 0. This guy is at the positive 24 meter mark, or 24 feet mark, okay? Now, their positions have to be equal at the end, okay? Almost, okay? So for my physicist, he was going at 16 feet per second for a certain amount of time, t, which is the same as the time for Anti-Science. And this one is starting from 0, so plus 0 equals Anti-Science is 12, the same amount of time, okay, plus 24, because it starts at the 24, positive 24 position. So if we do the math here, we get t equals 6 seconds. Okay? How far from the finish line did my physicist, this guy, put up the final effort? So you just have to take this 6 seconds and give it to my physicist. So you do 6 times 16. And I also tried it by setting this position here. So this is going to be 96 meters, it looks like, right? Okay. Setting this as 0, this is going to be negative 24. Okay, so now the x, my physicist, equals to the x for anti-science. So for my physicist, it's going to be 16t minus 24 equals 12t. So you can see that the 24 just changed places. So this is going to be 6 seconds. So if you want to find the position of my physicist, that's the position with respect to 0. How far away from the 0 he is. So you're going to do 16 times 6 minus 24. But if you want to find how far he's from the finish line, he's now 24 behind, so you have to add 24. So it ends up being the same thing, no matter what you do. Okay. In a bike race, Skylar, the biker, is in first place. Okay. So it looks like this. Skylar is here. Basil is behind her. And she has a lead L on him. Now, he's 200 meters from the finish line. Okay? She's going at 15 meters per second. He's going at 15.62. Okay? What is the smallest lead? Basically, we're trying to find this L, so that Skylar wins. So we're going to make them that they kind of come to a tie, and we just have to say, well, the lead should be just a little bit more than what we find. So maybe I can set this position as 0, basically, right? So I'm going to say x of Basil is equal to x of Skylar. Now, when Basil is at the finish line, his position is 200. Okay? Now, for her, it's going to be 15t, right, plus this L here. Okay? Because she starts from a position L, basically, right? I think that's how we did it. Yeah. Okay? And then we say t. Actually, we can figure out what the t is, right? Because we know that he's traveling at this speed, and he covers that distance. So I think his time, or the time for both, is the same thing. It's going to be 200 equals 15. The time is the distance over the speed plus L. And you should get an L equals to about 7.92 meters. Okay? You could have made this an inequality, right? You could have said, well, 200 is less. So in other words, her position is going to be a little bit higher. We can have done the inequality and we get L is less than 7.92. Okay. All right. So number 10. Two locomotives 1,500 meters apart approach each other on parallel tracks. All right, so I'm going to draw it here. So one is going at 50 kilometers per hour, and the other one is going in the opposite direction at 58 kilometers per hour. So we have to look at that as a negative. How long will it take them to reach each other in seconds? So I'm going to try this approach here. So I'm going to say, you know what, this is 0. So which means that this one starts from the positive 1,500 meter mark. And they're going to meet here somewhere, right? Yeah. Okay. So when they meet, they will have traveled the same amount of time. Okay. And they will be at the same position also, right? So we can try it this way. So it's 50t. Okay, so 50t will put this guy here equals negative 58t plus the 1500. And the reason we put the 1500 because this guy started at the 1500. So t equals, now when you find the t here, you're going to find it in hours, right? So it's going to be 1.5 divided by 108. Okay, so to change it to seconds, we just have to multiply by 60 basically, right? So if I do that, so 1.5 divided by 108 times 60, I should get, oh, that's in minutes, so times another 60. So I have to multiply by 3600, not 60. So this should give us 50 seconds, okay? Another way we could have done this, we can say, well, you know what, the distance traveled by this one plus the distance traveled by this one should add up to 1500. The distance traveled by this one is 50t, okay, plus the distance traveled by the other one. See, I'm talking distance here, so the direction doesn't matter. That should be 1500. And you will solve it like this. Okay? All right, let's look at number 11. A tourist being chased by an angry bear is running in a straight line towards his car. So the tourist is here, the bear is here. Okay? A distance d away, so the car is here. So this distance here is d. The bear is 26 meters behind. So I'm going to choose this as 0, which means the bear is at the position negative 26. Okay, so the bear is going at 6 meters per second, and the tourist is going at 4 meters per second. What is the maximum possible distance, the value for d? So I'm going to say, you know what, let's just say that they're going to get there at the same time. Then I will just, whatever value I find for d, I just have to go shorter, because longer means that he's going to catch him. So I just can't, common sense. So I'm going to say x for bear is equals the x for the tourist. Okay? Now, for the bear, it's going to be 6t for time minus 26. He starts 26 behind the origin. I chose this as the origin. Equals just 4t. And I think we can solve for t. And t will be 13 seconds. Okay? And then I just take that 13 seconds and plug it in for the position of the tourist, basically, where they're going to be after 13 seconds. So the d should be 52 meters. So technically, it should be less than 52 meters. Okay? Another way we could do it, I can change the origin too. I can make the origin here and make this at positive 26. You can do whatever you want to do. We can say that the time for the tourist has to be less than the time for the bear. Now, the time for the tourist is the distance that he travels divided by his speed. That should be less than the distance traveled by the bear is d plus 26 over his speed. And you can solve that inequality. Or you can make it an equation and find d and say, well, it has to be less. Okay. An 18-year-old runner can complete 10 kilometers with an average speed of 4.39 meters per second. So pay attention to the mixed units, right? This one is pretty straightforward. So I think what we have to do is just find the 2 times and subtract. So the t for the young runner is going to be distance over the velocity of the young runner, right? So this is going to be average velocity. So it's 10,000 divided by 4.39. T for the old person is going to be the distance divided by the velocity for the old person. So it's going to be 10,000 divided by 4.27. And find out what these numbers are, and you just subtract 10,000 divided by 4.39. So here I got 2277.90 seconds, because it's in meters per seconds. The other one, I get 4427, I get 2341.92. So if I subtract, okay, so I get about 64 seconds. Okay, so he has to start 64 seconds later in order to be for it to be a tie. Okay. 13. Mike leaves his house to school at the same time as his younger sister. He's walking at 2.5 meters per second, and she's walking at 1.7 meters per second. He arrives to school 72 seconds ahead of her. How far is school from home? So I think to do this, we have to realize that the positions are going to be the same at the end. So they both started from home, which I think I can look at that as 0, and they both are going to get to the same position, which is the school. So I think we're going to say, well, x of Mike is equal to x of the sister. Now, the position for Mike is going to be 2.05 t, but it takes him 72 seconds less time. Okay, so even though it says later or ahead, it means that it took him less time, equals 2.05 times t. And you would solve this for t, which I didn't. Yeah, I did. 492 seconds. Okay. Now, how far is school from home? You can just take 492 and plug it into either one of these equations, and you should get 861 meters. Okay, that's how you pretty much do this stuff. Now, if you don't want to do it this way, you can try, say, well, his time is t, it's going to take her 72 seconds longer. Okay? So if we solve that equation, we should get, did I mix this up? Okay, this is not supposed to be 2.05. This is supposed to be her speed, 1.75. So you can make that correction. So, so this is going to be 0.3 t equals, what's 1.75 times 72 equals 126. Okay, so t is equal to 420 seconds. Now, if we do it this way, that's the that's the time it took Mike, 420. Okay, so if we take 420 multiplied by 2.05, we get out 861. Or you can take 420 and plug it in here. So that's up to you how you do it. Okay, skip. This one here, I think we're just going to do it in class. All right. For number 1 on page 11, you're given a couple statements, and we have to figure out which one of these people are correct. Okay, so this person is traveling for 10 minutes at a certain speed, for 20 minutes at a different speed, and for 15 minutes at a different speed. So Aaron says, I think the average speed of the entire period is 18 meters per second, because to find an average, sum the 3 and divide by 2. First of all, there's something very wrong about that. Like, he's wrong 2 ways. You can't just take them and divide. And even if you divide, you have to divide by 3. But that is still wrong, because to find the average speed, you have to do the overall distance, total distance divided by the total time. You do not just take the single speeds or the individual speeds and add them and divide by 3 or 4. That depends on how many there are. Okay. Bessie says, I disagree. The average speed is 12 because you add 3 velocities, but you then just have to divide by 3. That's wrong. You can't do that, because you have these rates at different times, so it just doesn't work that way. Because the definition of average speed is total distance divided by total time. So Caesar is the one that's correct. Let's look at number 2. Now for number 2, I want you to pay attention to what kind of graph we're dealing with, and that's going to be extremely important in this unit. This is a velocity time graph. So in other words, if you want to read the velocities in time, you just go across to the y-axis and read those numbers, and that's your velocity. Okay? You don't do the slope here. If this were a position time graph, then we do the slope to figure out the velocity. This is not the case. This is it just reads. So if I want to find the velocity for B at this moment, just go up, come across, and find the velocity. Velocity of A at that moment, just go up, come across, and find the velocity for A. All right? So here it says B is faster. That's a wrong statement because A is always faster because the graph or the line for A is always above the line for B. Okay. This one is number 3 is a ball thrown up in the air and falls back. Okay, so they're giving us a velocity time graph. Now, if you think about this, basically what this means, it just means that the object, okay, starts with a speed. So when you throw it up, okay, right, and slows down to 0. But when it gets to 0, what it actually does is just continues in that same direction, but faster. Okay, so when it gets to the top, it just continues going up, but faster, which doesn't make sense because this velocity is always positive. This does not show any change in direction. So the correct way of doing this for this problem here, you have to show a graph, a velocity time graph, that's changing direction. So in other words, you have to have some positive velocities, some negative velocities, and a 0 in between. So this point here is the highest point. So if you think about this, when you throw it up in the air, we're thinking of up as being positive here, okay? Because you start with a positive velocity, and as you're going up, as you're traveling in time, your velocity decreases, okay? It reaches 0 at the top, and it changes direction, and this indicates the change in direction. If we choose down as positive, okay, the graph will look something like that, okay? Because you start going up, and we choose up as negative, okay? So as you're going up, your velocity is negative to start with. You get up to the top, it's 0, and you start to come back on the way down, which you consider positive, okay? So that's the reason that one is wrong. Number 4, again, it's a velocity time graph. It's not a position. So if you want to find the velocity of the boats, you just read the values. So I do have values here. I don't feel like doing them again. Okay. So this is a 0. I'm just going to read the value here. This is, I think I said -1, and I guess third or fourth. Okay. This one is about 1.5 positive. Okay. This is about -1/4. This is 0, and this is about positive 1 3/4. I think that's what I have here. Yep. Okay, so the ranking would be FB from greatest, and it looks like A and C are tied for 3rd and 4th place, and then comes, which one is bigger? So then comes E, and then comes D. Now, here, if they tell us, just to a sidetrack, if they tell us that we're looking to rank the magnitude of velocity, it just means you drop the negatives. So if it says the magnitude, you drop this, you make that a positive, you make that a positive, right? Then you rank them based on that. Okay, but it's not asking you for that. Okay, for number 5, now this is a position time graph. Okay, so here we're looking for speed, not velocity. So which means we're going to find the slope of these curves here, of these lines, and ignore the negative. If it had said velocity, we'll keep the negatives. So you just got to be careful with that. All right. So the slope of this here is, you can do rise over run, so it looks like it's 1/2 positive. Okay. So in terms of speed, I think I said that this was, what did I say? Drop of 2, so it's 2 over, I guess, 1.5. Okay. So which is basically 4 over 3. I think that's what I said. Yeah. Okay. And I ignored the fact that it's a negative slope. This is the slope here is 1 over 6, positive 1 over 6. The slope here is 1, 2, 1, 2, 3, 4. So it's 2 over 4, which is basically half. And when you're doing the slope, always pick the points that are furthest apart. This way, if there is an error, it's minimal. The slope here is drop 1 and run 6. Okay, so I'm going to do 1 over 6. Even I'm going to make that positive because I'm looking for speeds. And here I go 1, 2, 3, 4 over 3. So it's negative 4 over 3, but since its speed is positive 4 over 3. So the ranking would be C and D for first place. Okay, C and D. Yeah, they both 4 there, so I'm done with this. Then comes A and B. Then comes whatever is left. What is it? E and F. And they are equal. Okay, so you just have to be careful when you're dealing with these problems. You just have to be careful if it's a position time or if it's a velocity time. If it's a velocity time, you just read from the graph to find the velocity. If it's a position time, the slope will give you the velocity. If it's a speed, you drop the negative.